next 15 years will see a remarkable proliferation of commercial opportunities in space, from asteroid mining to orbital tourism. Now, I recently spoke with Mike Greenlee of MDA Corporation about those opportunities, and to George Randall of Siemens PLM about the systems challenges that engineers will have to overcome to make those opportunities a reality. Let's hear from Mike how MDA enables commercialization of orbital space.
Today we provide a lot of support to the global international space community in the areas of satellite ground systems, satellite components, electronics, payloads, and antennas, in addition to robotics and sensors for space exploration vehicles.
Satellites, of course, it's big business, it's getting bigger. The payloads themselves are getting heavier. I'm amazed there's any space at all left in geosynchronous orbit to do this, but we have new generations of sort of low orbiting constellations or clouds of satellites coming in down there. Where's the future, do you think? Where's the business going to be, say, 10, 20 years from now?
There's two elements right now that we talk about in terms of the new space economy. So one is the economy in low Earth orbit. As you mentioned, there's a bit of a shift from geosynchronous orbit closer to Earth and low Earth orbit, where our current International Space Station, for example, would orbit about 400 to 600 kilometers from Earth. In that orbit, we're seeing a lot of commercial activity. So the barriers to entry now are quite low. Many companies can now get access to a rocket for launch and put a satellite in orbit for Earth observation, for communications, for tracking things, or what have you. We see about 2,800 objects in orbit right now, with various studies showing us getting up to 20,000 objects in orbit over the next 10 to 15 years. So there's a whole market there then to provide the elements of that satellite market. As a result of that, there's also an emerging market for on-orbit servicing, where people can build satellites or spacecraft to go up and inspect, repair, and sometimes refuel, or to move around, change the orbit or deorbit a satellite to get it out of the way. So that's a brand new market. First market study ever in 2018 is a $3 billion market in the next decade. So you see a good market in low Earth orbit. And you see two other things: space tourism, with space tourism expected to be over $1 billion industry according to an FAA recent study, and then space mining, where one asteroid the size of a football field could have $20 billion worth of minerals on it. And there's about 18,000 of those types of asteroids that are accessible from Earth. So there's an burgeoning market with a number of different countries that are investing in their industrial bases, taking mining technologies from Earth and adapting them for space mining of the future.
Now, Mike, you're talking about asteroid mining, satellite servicing, geosynchronous orbit, for example, that's 22,300 miles up. So we don't think of this the kind of thing that an astronaut in a suit is going to go out and do. We must be talking about robotics here. Will this be automated servicing, automated mining, do you think?
In 2022, 2024, we'll start to be back in the moon with a new space station that's going to orbit the moon. So our current space station is 400 kilometers from Earth. Our new space station will be 400,000 kilometers from Earth, orbiting the moon. And definitely it's going to have a lot of robotics in it and automation to provide the support to astronauts who will now live on the moon, driving around their rovers and doing exploration and science, getting support from this new space station. So an incredible amount of robotics that'll be proven out on the way to Mars 10 to 12 years from now, when those next generation of space explorations will go from the moon to Mars, and even more robotics and automation will be a part of that. So artificially intelligence-driven next generation robotics is absolutely the centerpiece of the next generation of space exploration.
Now, Mike, you mentioned AI. The moon, 250,000 miles away, a little bit of latency. Asteroid mining, the asteroid belt, a lot of latency. So in terms of remote control, are these things really going to be on their own or have to think on their own up there?
They will, yeah. And if you look at some of the orbits around the moon, for example, for the new space station, you could go several days of being out of touch. So you have to send a command to say, I want these tasks completed. And then you might lose contact for a few days, and the artificial intelligence will be leading those tasks with fail-safe modes. Where if something goes wrong, it'll just pause, and you'll get it back when it comes around the moon, and it'll be paused if something went wrong. But largely, you're going to have its own brain that is running its instructions that you've given it with an artificial intelligence engine. A tremendous level of advancement compared to what we do today.
To achieve that level of robotics is the challenge sensors, actuators, structures, software?
On the robotics elements itself, because we've got 30 years of experience now in space robotics, the actual mechanical and structural elements of that, the actuators, the control systems, we have a lot of proven technology there that we can reuse and or introduce the next generation of those product lines. The biggest challenge is introducing the next generation of artificial intelligence into those control loops and massively advancing the level of autonomy of the robotics tasks.
George Randall of Siemens PLM gave us some insights into the capabilities of new design software that will be helping teams develop the systems of systems required to develop this new era of autonomous space vehicles. George, aerospace, of course, we think of structures, large pieces of hardware, but aerospace industry has advanced electronics, it has structures, essentially it has sensors, actuators, or software. So it's sort of all-encompassing sort of industry at this point. How do they get these folks to talk to each other? I come from a world where the structures guys never talk to the software guys, they never talk to electronics guys at this point. Is PLM the key to making that work, do you think?
Yes, we do believe it's the key. Of course, as you mentioned, aerospace structures and the products of the aerospace industry are really systems of systems. The impressive thing is the size and scale, and of course there's human safety factors and a whole bunch of other complexity that goes into those products. Some of the things that we're doing recently at Siemens PLM Software is the merger acquisition with Mentor Graphics. So with our NX mechanical CAD software, we're tying the mechanical pieces to the Mentor Graphics capital electronic systems. That allows our aerospace customers to mix and integrate the workflow to and from electrical and mechanical CAD to a single customer workflow and end-to-end process. What we have today in our current NX12 release with Mentor Capital and also with Mentor Expedition is cross-probing and integration of that data. So whether the mechanical CAD and electrical CAD user is the same user, perhaps at a medium or supplier aerospace company, or they're two different folks in a big enterprise aerospace company, that data moves back and forth without data translation and allows the mechanical CAD user to see the mechanical structure, the envelope for enclosure, and do what we call cross-probing to the logical schematics or to the cable and electrical routing on the Mentor side, and allows that to go back and forth the other direction. The key to that success is our Team Center backbone for PLM, which integrates all those users in an overall customer product lifecycle management solution.
Generative design and topology optimization are excellent tools for space applications because they can help tremendously with lightweighting, particularly when paired with additive manufacturing. Now I asked George what he sees as the future of software development that will support these efforts.
Pie in the sky, everything is coming to be. From our perspective, perhaps not quite out 10 years, but a little bit closer in time. The additive manufacturing and additive design is happening right now. Lattice structures, topology optimization, generative design, complementing the manual design from engineers. All of that, we have initial product releases in NX today to provide solutions, but I think that's an area of rapid innovation and it's going to change drastically over the next 2 to 3 years.
A prediction, how long? How long do you think from the point at which we see, for example, perhaps robotic orbital servicing, and then perhaps the next step, the moon, and then asteroids?
Yeah, on-orbit servicing, first projects launch in 2020. Some of those are our customers, which is really good to see. The new space station for the moon is currently targeted, the Lunar Gateway is currently targeted for 2024. And then most of the conversations around the first human missions towards Mars is in that 2030 timeframe. So not too far away.
So those are the predictions from Mike Greenlee and George Randell. We'll have asteroid mining and human missions to Mars faster than you think, and we'll have sophisticated software environments that will enable users to pass data rather than files between mechanical, electrical, and electronics designers to make those complex system of systems fly. It's an exciting time to be an engineer. Aerospace in the Montreal area has a long history, I understand.
Indeed, for many years actually, there's been expertise and lots of strength towards the aerospace. It's one of the largest aerospace hub in the world actually, and we're very proud, very dynamic as well. Lots of opportunities and R&D being done here.
Now, historically, many areas are airframe-centric, some are engine-centric, but I understand in the Montreal, it's both. I mean, Rolls-Royce is here, Pratt & Whitney is here, Bombardier, and many, many other contractors.
Indeed, actually, it's one of the only places, if not the only place, where you could build a whole airplane within 100 miles.
Tell me a bit about my HTT.
So we basically, 35 years ago, started actually from the space industry and grew into other areas. We've been working as well with Siemens for 35 years. That relationship was symbiotic. We've developed technology. We've grown to be one of their largest technology partner, focusing on development and R&D in the simulation area.
Now, simulation strictly aerospace, or do you serve other industries also?
We serve other industries. So we started from the aerospace. Aerospace is still a strength, but we've grown into other industries and actually are also being involved into Industry 4.0 and other initiatives which are going across all the industries.
Now, simulation, of course, is around a long time. Industry 4.0 is relatively new as a concept at this point.
It is.
Is simulation going to be an essential brick in that Industry 4.0 wall?
Definitely. The digital twin, where the simulation is at the center of, is essential for Industry 4.0 to take place. You need to be able to simulate things in order to have the right physics to develop faster and to be able to build everything that will be the milestones for being able to optimize and capture real-time data and optimize on a continuous basis.
Now, Mark, historically we think of design and manufacturing of a product, but what about jigs, fixtures, tooling, the machines that make the products in the end? Simulation, Industry 4.0, digital twin also useful here?
Very much. It goes even beyond that. It would go into the process. Simulation was historically, yes, it came from Aerospace, so R&D was, I guess, used in other areas throughout the years, but it came from there. Now we're modeling processes, which could be a baking process, people helping, people making breads as an example. Historically, you would not have considered to be a technology issue, but it is. So in all areas, in all industries, we see simulation and digital twin making a difference.
In the future, Mark, do you expect that when we build a new factory, greenfield or retrofit a factory, before we clean it out and think about organizing assembly lines, process flow, this kind of thing, will engineers be strapping goggles on and then walking through a factory virtually?
That's going to be one of the ways of doing it. Certainly the goggles and the VR are a key part of what could be done, but there will be many other ways. What's going to be important actually, it's not only the product, it's the product, the factory, and thinking of what the product will, how it will be used. Those three have to be brought together in order to have an efficient digital twin that will be enabled.
Now, it's outsourcing, globalization, of course, it's the new trend now. A company may have a vendor base that is literally around the world, and all the sub-assemblies and components must come together, they have to fit, they have to work at the same time. Is this kind of global collaboration, is that a factor here?
So for us at Maya, one of the things that sets us apart actually is integration and democratization. Integrating different technology from one vendor or multiple vendors. So the integration, bringing everything together is a key, and enabling people which are not analysts, which are not structural analysts, as an example, we need to do both in order to have this to be efficient, or to make it real and make it efficient.
Does this go beyond the engineer? Does this go to the front office? We're talking about senior management at this point?
Well, actually, as some examples, we're doing MDM multidisciplinary optimization, which will include cost, which will include materials, which will include shipping, logistics. All aspects are being impacted.
So ultimately, will we have one piece of software that will run your entire business from the loading dock at the back to the financial planning at the front?
No, because actually there will always be initiatives which will come from areas, different areas. Well, what you will get though, actually, all those software will talk together. That indeed will happen.
Will aerospace be the industry that leads implementation of this advanced software?
Well, they have strengths in some areas, and definitely in those they will. So technology, lightweighting, all those things are key in aerospace. Definitely they will lead in those areas. But they are also learning from other industries, such as automotive, as they have more volume in automotive. So some learning, actually it goes both ways.
From baking bread to space boosters, advanced PLM will be the future, says Marc Lafontaine of Maya HTT.